It's the sum and difference rule, so this is just the sum and difference of derivatives. It's pretty straightforward in the sense that if you're adding two functions, if the derivative of the two functions added is the derivative of them separately. So all that means is if you have a sum or difference, you can take their derivatives separately. Okay? So if I'm doing f prime, like if I have two pieces, which we'll get to, you take the derivative of each separately. That's all it's saying. There's no special rule for it. This is very straightforward. That's why I'm not going to spend a ton of time on this here. Okay, so this is what they kind of mean here. Sorry, do we need more here? Okay, just again, so all this means is f plus g prime equals f prime plus g prime. Separate is the same as together. And then if you're doing f of x plus g of x, the derivative of it, you can do them in two separate parts. Whenever you see this Leibniz, okay, notation, it's d of dx. That's Leibniz or whatever. Actually, I'm not really sure how to pronounce that. It's kind of weird. What's that? What would you guys guess be? Leibniz. So I'm okay? All right. So the sum rule can be extended for subtraction. So simply subtraction is the same. Okay, subtraction of two functions. The derivative of that is them separate. Okay, it's a difference rule. That's why we're going quickly today. This is very easy. It's going to be very similar to yesterday. Product and quotient rule, doing them together will be good. So if we get through that, that'd be great. I wouldn't really write this down up here very much. If you want to write the difference rule, that's great. The top's just repeating the idea that if you have 3, you can do 3 separate, which I don't think you need to write. Okay, if you don't know what it means by separate, what it means is if I do these here, I do the derivative of this and this separately. I don't have to do any weird distribution or anything like that. It just means that when I'm doing 2x4, the derivative of 2x4 is 8x3, right? Everybody okay with that? The 8x3, I hope that's the automatic one. Root x, a little more difficult. We want to write it as x to the 1/2, drop the 1/2. So it's going to be plus 1/2, and then it's going to be x to the negative 1/2, which we can also write as 1/2 root x. That's from our notes yesterday. If you weren't here, make sure you watch the video. 8x cubed plus 1/2 root x. That's the derivative of 2x4 plus root x.
So you do them separately, you break it apart.
Essentially, yes. You do. Yep. So I got 4 to do. Okay. So derivative of this one. Okay. So g prime. This one should be pretty straightforward. There's no ugly things in here. 24x cubed minus 15x squared plus 2. 17, 0, right? Derivative of x is 1. So that's why the 2 is just a 2 now. This is just a 2 here. Again, I'll say this again. These represent the equation of the tangent line, how the tangent line is changing from the original. So this is the equation of the tangent line to this graph. Okay, get that down in your head. Yeah, Nikita. Minus 2, yep, minus 2. Minus 2, minus 2. Thank you. Minus 2, because it's just a minus. Signs don't change in this example. Okay. So how about this one? So this one, you're going to learn the chain rule later, which we will use for this. But since you don't know the chain rule, what would you do with this to try to make it easier? We'd like to have it in pieces, right? So FOIL it out. Write it. Like that, and FOIL it out. So it's going to be x squared minus 2x root x minus 2x root x plus 4 over x. So I could write these with all positive x, or not positive exponents, but all as exponents. So x over root x, what would that simplify to with your exponent laws? So this is 1 over 1/2. So what do you do with your exponents? You subtract. So it's 1 minus 1/2. Okay, this right here, if I combine this, okay, that's a negative 4x over root x, right? This is x over x to the 1/2. 1 minus 1/2. That's what it simplifies to. Minus 4x to the 1/2. Anybody want me to explain that again? Okay, so root x is x to the 1/2. This x has nothing there, so it's a 1. These are the same base, so we can do exponent laws. 1 minus 1/2 is a 1/2. Because it's positive, it's on top. So we don't have anything down here anymore. So it's the same thing as if I was doing, if I had that, right? 2 minus 1 is 1, so that's just this. Well, this case, yeah, 1 minus 1/2. Okay. Any other questions on that? Am I assuming you know something that you may not? Okay, and then to write this one with exponents, it would be plus 4x to the negative 1. Now I have them all with exponents. Okay, I have them all with exponents, so now I can drop them. Okay, we can do our power rule. Okay, so we have 2x here minus 2x to the negative 1/2. 1/2 of 4 minus 1's a negative 1/2. We'll take care of that in a second. Negative 4x to the negative 2. (2x) minus 2 over x to the 1/2 minus 4 over x squared is writing with positive exponents. It just got moved down. It's helpful to. I'm not sure if the direction specifically asked off the top of my head, but I usually do. But then again, Chris, it's like a situation where sometimes it helps you to, and sometimes you don't need to. Okay, anything else? Yep, 2 over root x. Yep. All right, so find the equation of both lines that pass to the point 2, 9 and are tangent to the parabola 2x minus x squared. Sketch the parabola and the tangents. Okay, so find the equation of both lines. So the tricky part on this one is the sense that we do want to go ahead and think about it in terms of, okay, so just a second here. The A thing now. Okay, sorry. So the thing that's different about this one, initially what I kept thinking, we were still doing the easy stuff. This is where things get a little bit more complicated because it's not giving us the point that it's actually tangent to. It's just giving us a point. So therefore, we have to generalize, and we have to use this idea, which we've used, MPQ. Okay, we're going to make 2a. I'll explain where I got this. Over a minus 2. Because what we're doing is we don't know. This is an unknown point for us. We don't know what that tangent point is, so we use A. Okay, so again, find the equation of both lines that pass through a point of 2, 9 and are tangent to the parabola. So we don't have the point that's actually tangent. Okay, but we know it's going to go through 2 spots. And so this represents the unknown point. If you can see where I got this, this is like x. This is 2x minus x squared. I'm just using a, so I don't use x's again. Okay, and then we're going to do our other point, which we know is the 2, 9. And so we're doing y minus y, x minus x. So we're just doing our slope formula. Yeah.
Is that a 9?
Yes, this is a 9. That's why I was struggling with my notes. I was like, is that an A or 9? It's a 9. And it comes from right here. Okay, so let me explain that again. We can't just jump to saying we're going to do the derivative and plug 2 in to figure out the slope, because it happens at 2 spots that we don't know. And so these are our unknown spots, and this is the point we do know that's going to happen. So we're essentially finding the slope between those 2. Okay, you're going to see why, because we're expecting 2 answers. So watch what happens here. So now, the next thing we're going to do is we are going to factor the top. Okay, so factoring the top, 2 times negative 9. We get negative 18. Factors of negative 18. Oh, nope, I have it wrong. Sorry, what am I doing? I got to put it in order. We have to have A, B, C, right? Like that. Yep. This? This? This is just y minus y. Slope formula. Right? MPQ, M slope. Okay, so this right here is our point P. This is our Q. Our Q is the unknown. Okay? Okay, so sorry, now we can factor this. So you can pull a negative out if you want, or you can leave it in. It doesn't matter. Essentially, I'm going to pull it out just because it looks a little bit easier. Okay. Okay, so this right here is equivalent to what, though? So this is where we do want to use our derivative. All right, hold on here just a second. This slope right here should equal the tangent slope. The tangent slope would come from the derivative of this, which would be 2 minus 2a. We'll leave them as a. 2 minus 2a. And you're going to see how we're going to get 2 answers now, because typically, guys, let's just refresh really quickly. What is something you remember from Math 20 was a situation we got 2 answers? Yeah, zeros from factoring, right? Parabolas. You're looking at parabolas right now. So we're going to get 2 answers when we factor. Okay, so here we go. I'm going to multiply the a minus 2 over. Okay. Oh, still don't have room. That's a 2 there. Doesn't give me room there. Okay, so we're going to FOIL that out and now move everything over to one side. So this FOILed out. So I'm going to do that on the next page. So this is a squared plus 2a minus 9 equals 2 minus 2a. Our derivative, our tangent, equals a minus 2. We multiplied this a minus 2 over. This negative is right here. Oh, yeah. Yep, thanks. Thanks. Gotcha. I probably won't actually need to do that. No, because I was trying to factor that top, which I don't need to factor. We'll handle that in a second. So then I have them both backwards, huh? So this is minus 2a? Okay, I'll probably end up putting that back in, so don't worry about it, but it's fine. Okay, so on the next page, I'm going to write that. Is everybody okay? Everybody have it down? Okay. So it's going to be, I'm just going to write the negative a squared minus 2a plus 9, right? Equals 2 minus 2a times a minus 2. And now I'm going to FOIL that right side out. I'm going to go ahead and put this in here so I can combine like terms. So let's just switch that back. Sorry for the waste of time there. Okay, 2a minus 4 minus 2a squared plus 4a. Okay. Okay, and now we're going to move everything to the, I'm going to move to the left so I get positive a squareds. Because right now we're just solving for a. This is a 9. Okay. Yeah, Emma. Are you good? Okay. It's okay, I've been making mistakes, so questions are good. All right. So we get a squared minus 4a minus 5 equals 0. And that's factorable, which is the end game here. So our two possible a's are 5 and negative 1. 5 and negative 1. So what does that represent? That represents the two possible points. So now we have to plug them into the original. We have to plug them into the... So plug 5 in here. 10 minus 25. 10 minus 25 is negative 15. So our first point of tangency is 5, negative 15. Our other point, negative 1. Negative 2 plus 1 is minus 1. Negative 2 minus 1. Gosh, thank you. Man, I'm really not doing well. Sorry. I said it, but I didn't do it. Negative 2 minus 1. Because it's squaring the negative 1, but it's still minusing it. Okay? So these are the 2 points at which are tangent to that parabola. So 5, negative 15, and negative 1, negative 3. So in terms of why there's 2, this is probably going to help quite a bit. Okay? Does everybody have this? Is there any questions of this? Did I have a mistake? Everything good? I know that's the right answer, but okay. So let me explain what's going on here. You have the parabola that they gave you, 2x minus x squared. So we know that that looks like this. So it goes through, essentially it looks like this. That's what it looks like. The 0.29 is right there. So what it's saying is there is 2 slopes that will go through that parabola at one spot. So the one that we got essentially was, essentially the picture would look like this. It could come through like this, and it could come through like this, and hit it like one spot on each side. Essentially what's happening. Obviously my drawing is by hand, so it's not great at all, but that's what's happening. The point is above the parabola, and it can go through one spot on both sides of the parabola. So that's why there's 2 points. If you're saying, why can't we just plug the point in? Okay, it's because this point is not on the parabola. I think that's the thing I probably should have said at the beginning. 2,9 is not on that parabola, right? It's not part of that function. Okay? All right, so that's it for this one. Okay.